Science fiction writers have long dreamed of metal bodies, people using machines to help them when their bodies fail. Now, that dream is slowly becoming a reality. In the early 1970s, scientists recombined genetic information, DNA, in a test tube in vitro. With the discovery of recombinant DNA technology, it became possible to modify microorganisms for different industrial applications. This was the beginning of modern biotechnology. This term refers to any technique that uses living organisms or parts of organisms to make or modify products, to improve plants or animals, or to develop microorganisms for specific purposes are good examples of biotechnology outcomes. This way, cows may produce more milk. Good bacteria can help the body fight diseases. Chemists produce body cells or organs to replace damaged or injured ones, etc. The age of the biotech body is here, thanks to tissue engineering. This new field attracts all types of specialists: surgeons, chemical engineers, materials scientists, and genetic researchers are some of them. They have been working on different projects. Regenerated or lab-grown bone, cartilage, blood vessels and skin are now all being tested on humans. Livers, hearts, pancreases and fingers are taking shape in the lab. This is not science fiction. Now we are able to implant artificial grown organs and tissue into a living organism. A perfectly formed human ear was grown from human cartilage cells by tissue engineers at MIT and the University of Massachusetts. It was implanted on the back of a mouse. In Boston, a team of scientists and surgeons implanted the first chest, grown in a lab, into Sean. He was born without cartilage under the skin on the side of his heart. But how do scientists do that? Start with a scaffold made of an artificial biodegradable polymer. Seed it with living cells. The cells multiply and fill the scaffold. Once implanted into the body, they recreate their proper tissue functions. Blood vessels attach themselves to the new tissue. The scaffold melts away, and the lab-grown tissue is eventually indistinguishable from its surroundings. This is one method developed by specialists to cultivate tissue in the lab. Scientists discovered that even though a body part is gone, the network of nerves which connect it to the brain still works. With this knowledge, they can program machines to pick up signals from the brain so people can operate them just by thinking about the action itself. After losing her arm in a car accident in 2006, Amanda Kitts couldn't pick up items, drive a car, or do other everyday things. Now she has the opportunity to replace the missing arm with a robotic one. The same principles apply to deaf or blind people. Jo Ann Lewis, a blind woman, can now see the shapes of trees using a tiny camera that connects the nerves around her eyes. However, this technology is still very new, and some people do not respond well to the treatment and have to stop. Jo Ann still cannot see clearly or even cross a road. But it won't be long before scientists succeed in joining man and machine. The best ideas often appear from outside the big bureaucracies, say experts. This is also true for biotech companies in different fields: environment, medicine, food, etc. Some years ago they competed among themselves, but today they work together. The big companies provide the money and the marketing, whereas the biotech companies provide the ideas. This way we can produce unlimited quantities of newer or scarcer products. These are at the same time cheaper and, of course, safer. Biotechnology is changing the industrial community of the 21st century.